Good afternoon, I am Mr. Ish. Thank you for joining me for this video. We are exploring exponential functions. You will see these anywhere. We are looking at a function which has a designation f of x, but then the exponential is demonstrated by means of this exponential base e with an exponent x. And you know you can have a variety of these. You can have e to the x plus h plus k, where this right here is your exponent right over here. You can even have e to the x minus h minus k. You can have a whole variety. Actually, you know what? We can very well demonstrate it as this plus or minus e x plus or minus h plus or minus k, with having the reflective, the translation up and down, the horizontal, all of that coming into play. Very quickly, if you look at this exponential function, you have a graph which looks something like this. If x here were equal to 0, you'll have e to the power of 0. You're basically looking at f of 0 is equal to e to the 0, which is equal to 1, which is why you have a good y-intercept of 0, 1. These x plus h, x minus h, basically when you're looking at x plus or minus h, you're looking at right and left horizontal translation of this specific point. Will either translate here for an x minus h or it'll translate here for an x plus h. You have all of that effect coming into play. When you have this e to the x plus or minus h plus and minus k, then that plus and minus k will shift this point either up or it'll shift this point down, assuming this were your starting point. But you have to keep all of these translation effects in mind. Let this be our first question. We have a function e to the power of x minus 3 plus 2. We have to find f minus 1 over 2, as you see, and we have to find the y-intercept. We will do the y-intercept first because that's easy. Remember, at the y-intercept, the x-axis value is always 0, and you have some sort of y value which comes about, and you can determine this by simply doing this. Plugging 0 in places of x, you'll have e to the power 0 minus 3 plus 2, you'll have e to the minus 3 plus 2, and then you can write that as 1 over e cube plus 2. If you write this in this y-intercept form, you'll have 0, 1 over e cube plus 2, and that right there will be your y-intercept. You can calculate this using a calculator. You don't have to. This answer right here is just as good enough. To find f of minus 1 over 2, this was my first part. Second part, you just have to basically plug minus 1 over 2 in place of x. You'll have e to the minus 1 over 2 minus 3 plus 2. This here is the exponent. Minus half minus 3 is a minus 3 and a half, which is really e to the minus 7 over 2 plus 2. This minus 7 over 2 can be rewritten as 1 over e to the 7 over 2 plus 2, which you can write using properties of radicals as 1 over root of e to the 7 plus 2, and this here would be a good answer. If you want, you can always calculate this using a calculator. You know you're looking for the natural log button, natural log with e to the x. You would have to hit the shift button to activate this e to the x. Basically, to do e to the 7, you'd hit 7, then you'd hit the shift button, then you hit the natural log, it'll activate e to the x, and then you'll hit the equal button, and it'll give you exactly the value of e to the power of 7. You can then root that and hit the reciprocal and then add 2, and you'd be done. But this question here has been completed. For the second question, let's do this. We'll examine the attributes of the exponential function. You know very well, I've shown you the graph. The e to the x looks good like that. It goes here through 0, 1. In terms of the domain, you know clearly from left to right is going minus infinity up to positive infinity. The range is not hard. All of this graph, in terms of this presence here in the negative x coordinate, it will slowly dip down towards the x-axis. It will attempt to reach, but it will never reach 0 in terms of the y values, because you're going, in terms of the range, the vertical extent of the graph. You'll go from 0 up to infinity. It's a continuous function because there's absolutely no break in this function. You can trace it in a clear manner. In terms of increasing and a decreasing function, it is purely increasing. From left all the way up to right, it only goes up in terms of its y values, always increasing as you follow this curve. For this specific e to the x, it's an increasing function. Additionally, you know very well it has a y-intercept of 0, 1. It has no x-intercept because there's absolutely no way you can get a value here in terms of anything on this function touching the x-axis. Think about it. To get an x-intercept, y must equal 0. You have 0 is equal to e to the x. You solve for x. X is equal to a natural log of 0. You take e on the other side, it becomes natural log of 0. Check on your calculators, hit 0 on natural log, and it'll be undefined. It's an error. You can't do it. So there's absolutely no x-intercept of the exponential function, as you see right here. And that right there is a very excellent fact to know, and I've shown you why. Because the inverse of exponential is a natural log, and a natural log of 0 in terms of an input does not exist. As a culminating event to this specific question over here and the function, exponential function, it by no means is a true attribute, but we can show you all the reflections of e to the x there. Very nice to see. If you have here 0, 1, e to the x looks just like this. But if you have e to the minus x, it would look something like this. That's e to the minus x. This minus here makes a reflection of e to the x but across the y-axis. If you have this graph right over here, and this right here is 0, minus 1, this right here is a graph of minus e to the x. It's a reflection of e to the x but across the x-axis. If you have this little graph over here, you're looking at minus e to the minus x. This right here is a reflection of e to the minus x but across the x-axis. When you compare this minus e to the minus x to this right here, you're getting a double reflection. You're getting a reflection across the x-axis and a reflection across the y-axis. These two right over here, this and this is a double reflection of that, but each of these other ones are just single reflections of your basic curve. These are all important reflections to know: e to the x, e to the minus x across the y-axis, minus e to the x across the x-axis, and then minus e to the minus x, a reflection across x and y-axis. With that, I bring this video exponential function to a close. Hopefully you enjoyed this video. Thank you for watching. Have a nice day.